Hello everyone. Let's continue to the inversion using partial fraction. The function to be considered here is in the form of the rational function depending on s. For example, if you have the numerator and then you have the denominator, where the degree of the denominator over here is greater than the degree of the numerator, or else a long division must be performed. The forms of the partial fraction depends on the kind of the factor of the denominator, which either real quadratics or linear. Alright, okay, let's go to the types of the partial fraction that we will consider in this part. Okay, the first one is a linear factor, where the linear factor is, where the linear factor is, you may look at the denominator over here. So we call it this one as a linear factor, and then the partial fraction form is for this one. Okay, if you have the linear factor but it's repeated, means that it has a nth power, so the partial fraction form is continuous until your end. And then the third one is a irreducible quadratic factor, which means that the denominator over here cannot be reduced to become a separate factor, just like previously. So the partial fraction form is directly over here. And then the last one, if you have the irreducible of the quadratic factor in its denominator with power more than 1, so it will continue until ends over here. Okay, if you are not really understand, let's continue with the exercise. Okay, let's say if you have 3s plus 11 over s squared minus s minus 6. Previously, we did counter this type of equation. We need to completing the square. Alright, however, for this one, we would like to use the partial fraction. Okay, so before we go for the partial fraction, we need to check. Okay, the denominator here is either can be reduced to be a linear or not, or is not the cannot be reduced, which means that it's irreducible. Okay, so you may find the roots over here, and then you will find that the denominator over here is actually s minus 3 and s plus 2. Okay, according to the table over here, it's the first case where we can replace it with the a1 over s minus 3 plus a2 over s plus 2. Okay, so is actually this one. Okay, this one we have a 3s plus 11 over s minus 3, and then we have s plus 2. Okay, so it's equal to a1 over s minus 3 and then a2 s plus 2. Okay, according to this one, we need to make it the denominator here is just like the left hand side. So what we can do it, we can multiply crossly, where you will get a1 s plus 2 plus a2 s minus 3, and then you will get the denominator over here, it's the same with the left hand side. Okay, look at here, it's same, right? Okay, So means that we just need to match in the left hand side, which is 3s plus 11 with the right hand side. So you expand this one, so you will get a1s plus 2a1 plus a2s minus 3a2. Okay, you factorize the one that having s over here, so you will get a1 plus a2 s plus 2a1 minus 3a2. Okay, by comparing both sides, left hand side and then the right hand side, so we have a1 plus a2 is equal to 3, and then we have 2a1 minus 3a2 equal to 11. So now what is our a1 and our a2? So for this one, you may use your own creativity. I believe that you have the knowledge to find the a1 and a2. Alright, okay, so you may use the substitutions, or you may use the calculator, or you may use your own technique to find a1 and a2. Okay, let me teach you how to find it by using the substitutions. Okay, so from 1, you will have a1 is equal to 3 minus a2, and then you substitute a1 into the equation 2, so you will get 3 minus a2 minus 3a2 equal to 11, and then you have 6 minus 2a2 minus 3a2 equal to 11, and then you will have 6 minus 5a2 equal to 11, and then you have minus a2 equal to, okay, 11 minus 6, you will get 5, right? Okay, and then you will have a2 minus 1. Okay, all right. Okay, and then you may find the a1. So your a1, you will get, okay, now your a1 is 3 minus, and then you have minus 1, so your a1 is 4. Okay, so now you insert back to the equation that you represent the equation, okay, which is you have a1 is equal to 4 over s minus 3, and then you have minus 1 over s plus 2. Okay, s plus 2. So that you just need to take in the inverse Laplace for this expression. Okay, taking the inverse Laplace for this expression, okay, we'll give to you, okay, by looking at this one, you may refer the table, and then the table telling you that you will get the 4 exponent 3t minus with the exponent, okay, exponent what class? Okay, so here is plus, so it's minus 2t.